Every day, cities lose billions of liters of drinking water before it ever reaches a tap. But now, engineers can detect leaks before they even happen. And that's just the beginning, because the world is running out of water. At 6:12 a.m., a control room screen flashes red. A pressure sensor buried beneath a city street has detected a tiny drop in flow, the earliest sign of a leak. Within seconds, software analyzes the anomaly, pinpoints the location, and alerts a maintenance crew before thousands of liters disappear into the soil. Thousands of miles away, sunlight glints off a massive coastal desalination plant, where seawater is being transformed into drinking water for millions. And in another city, something even more surprising is happening. Water that once flowed down the sewer is being purified and returned to the tap. These technologies might sound futuristic, but they are already part of a global engineering effort to solve one of the most urgent challenges of the 21st century. We have always assumed rain would fall and rivers would flow. That assumption, it's breaking. Fast. Droughts are longer. Rainfall is unpredictable. Infrastructure is aging, and over 2 billion people already live under water stress. But the water crisis isn't just about scarcity anymore. It's about engineering. So where do you get water when there isn't any? The ocean. Seawater makes up 97% of the planet's water supply, but its salt content makes it unsafe to drink. For centuries, turning seawater into fresh water required enormous amounts of energy and complex distillation systems. Today, the process has changed. Modern desalination plants use reverse osmosis, forcing seawater through microscopic membranes that block salt while allowing water molecules to pass through. What emerges on the other side is fresh drinking water. These facilities now operate at enormous scales. In parts of the Middle East, desalination plants produce billions of liters of drinking water every day. Coastal cities around the world are increasingly turning to the ocean as a strategic water reserve. Even Cape Town, South Africa, which came dangerously close to running out of water during the 2018 Day Zero crisis, deployed temporary desalination plants to help stabilize its supply. Desalination still requires significant energy, but engineers are steadily improving the technology. New membranes are becoming more durable and efficient, and many facilities are now powered in part by renewable energy sources. But this isn't the most surprising solution, because the next source of drinking water is wastewater. Water we flush away is now being purified and reused. For most of modern history, wastewater treatment had a simple goal: remove dangerous contaminants and safely discharge the remaining water back into rivers or oceans. But that approach wastes an enormous amount of usable water. Today, advanced treatment systems are changing that. Using combinations of microfiltration, reverse osmosis, and ultraviolet disinfection, engineers can purify wastewater to meet, and sometimes exceed, drinking water standards. Singapore has become a global leader in this approach. Its highly treated reclaimed water, known as NEWater, is blended into reservoirs and used for both industrial and drinking supply. Instead of discarding water after a single use, cities can now recycle it again and again. This creates what engineers call a closed-loop water system, dramatically reducing dependence on rainfall. But even as cities search for new sources of water, engineers are confronting another massive problem hiding beneath our streets. We're losing huge amounts of the water we already have. In some aging urban water systems, up to 40% of treated water is lost before it ever reaches homes. Pipes crack, joints fail. Corrosion eats through metal buried underground. In the United States alone, an estimated 6 billion gallons of treated water are lost every day through leaking infrastructure. For decades, utilities discovered leaks only after water surfaced in streets or bills spiked unexpectedly. But modern cities are beginning to build something called a smart water grid. The smart water grid is a network of sensors embedded in pipelines which measure pressure and listen for the faint acoustic signature of escaping water. Artificial intelligence systems analyze the data in real time, identifying leaks long before they become visible. Cities like London are investing heavily in these systems, conserving millions of liters of water each day. These are the systems most people never see, but depend on every day. If you're curious about the engineering that keeps our world running, from water and energy to transportation and infrastructure, consider subscribing to Engineering Your World. We explore the systems most people never see, but everyone depends on. Some of the most valuable water reserves lie hidden deep underground. Groundwater stored in aquifers has long served as a backup supply for cities during dry periods. But in many regions, these underground reservoirs are being depleted faster than nature can refill them. Engineers are now turning to a technique known as managed aquifer recharge. During heavy rains or floods, excess water is diverted into specially designed infiltration basins, where it slowly seeps into underground aquifers. In parts of California, floodwater that once rushed uselessly into the ocean is now captured and stored underground for future droughts. Storing water beneath the surface dramatically reduces evaporation losses while creating a long-term reserve for cities. Cities are also rethinking rain itself. For decades, cities covered natural landscapes with asphalt and concrete, funneling rainwater into storm drains as quickly as possible. Now many cities are reversing that approach. Permeable pavement allows rain to soak into the soil. Green roofs absorb rainfall and reduce runoff. Constructed wetlands filter stormwater naturally while providing habitat for wildlife. In Copenhagen, entire parks have been designed to double as flood basins during heavy storms. These nature-based engineering solutions help cities manage water more sustainably while improving urban environments. But one of the biggest transformations is happening outside city limits. In agriculture, traditional irrigation systems waste enormous amounts of water through evaporation and runoff. Modern precision irrigation is changing that. Using soil sensors, weather data, and satellite monitoring, farmers can deliver water directly to plant roots in carefully measured amounts. Drip irrigation systems pioneered in places like Israel have demonstrated how crops can thrive in extremely dry environments using minimal water. And then there's this: machines that pull water directly from the air. Atmospheric water generators use condensation technology similar to air conditioners, extracting moisture from humid air and purifying it for drinking. These systems are already being used in remote communities and disaster-stricken regions. While atmospheric water generation is unlikely to supply entire megacities anytime soon, it represents another tool in a growing engineering toolkit. And that toolkit reflects a major shift in how humans think about water. For most of history, water followed a simple path. Take it, use it, discard it. That system no longer works. Now we're building something new, a circular water system. Because by mid-century, billions more people will depend on these systems. The infrastructure we build today will decide the future of entire cities. The next time you turn on your faucet, it will feel simple. But behind that moment is a system under pressure, constantly adapting, constantly evolving. Because the future of water won't depend on nature alone. It will depend on engineering.